constant folding, which is a simple form of constant propagation. Then look at constant propagation before SSA form and then with SSA form. So constant folding is a term used to describe a simple evaluation of arithmetic expression. Languages such as C and C++, they have very exact rules for what the compiler is required to evaluate. For instance, taking the difference between two array elements will, if the indices are constants, then that will create a constant, but that's not actually regarded as a required expression evaluation in the ISO standards, because it's a little bit too complicated. So to exactly what is required by the language in constant folding, please look it up in the relevant standardization document. But you can see it as simple expressions, okay, such as this one, okay. For floating point expressions, at least C and C++ require them to be evaluated and give the same result as if they were executed at runtime, which means that the rounding mode must be the same as at the runtime. And the program can have changed the rounding mode from the default, and then that can complicate what should be done at compile time. I mean, it can prevent what can be done at compile time. But if the expression is for a static variable, then it's the default rounding mode, which is the compiler is allowed to use the default rounding mode. So then it's easy. Before SSA form, there was an algorithm invented in 1973, which is quite powerful, but not as powerful as the one on SSA form. Every variable can have 3 different states, so to speak, lattice values. Undefined, then we don't know the value. Constant, it's a known constant, or non-constant, we know it's not a constant. Okay, and then we perform iterative data flow analysis and propagate the information as much as we can. And whenever we discover that there are 2 different values, 2 different constants assigned to a variable, then it's regarded as non-constant. It's also regarded as non-constant if it's returned from an unknown function or read as input. Okay, so what happens here? Well, since C is defined either as 3 or 4, the iterative data flow analysis will conclude when it comes here that C is not a constant. So it will be regarded as a non-constant. This can be handled by the algorithm we will see soon on SSA form, and which you will implement as part of the project. Well, there are 3 parts of the project, 2 of them in the VCC compiler and 1 on in LLVM. Okay, so this was invented at IBM, and the idea is to not use iterative data flow analysis, but instead to assume that nothing except the start vertex can be executed. And then interpret the program starting here. So we still have the same lattice values as in Kildall's algorithm. And here A is given the value 1 and B 2. But now when we interpret this if statement, we conclude that we will go to this part here since A is less than B. And then we will interpret this statement, so C1 will be 3. This one is not interpreted. And then when we come to the phi function, the key idea then is to ignore this operand because it has not been executed and it will not be executed as far as we know from the moment. Okay, so well, if there would be an operand with the non-constant value, then the value of the phi function would also be non-constant. But in this case, only one operand will have a constant and the other can be ignored, since as far as we know, it will never be executed. And that means the value of the phi function will be 3, and so we can use 3 here. Put and get are two functions which are used to print on the screen and read from the keyboard, from its standard input. And they are instructions, machine instructions in the VCC simulator and library functions when the program is compiled with GCC. The benchmark program used in the project.